But so I would like to show a little bit. Can I share my screen?
Yes,
Yes,
please.
please.
So Klaus asked me to show some of the reports we have. Okay, let me try to share my screen. All right. So that's the correct one. Let's go. So here, this is our whole suite of tests. This is one of the projects. Okay, and this specific suite has 39,046 tests, right? So this is the name of the suite of tests. One thing that is interesting about our framework is that, well, from the beginning, we decided that we wanted to have all of the reports stored in a database. So every time a new suite of tests starts, we call the suite of tests execution turn, right? So the execution turn is the same thing as the suite of tests, right? And for each of the execution turn, we have all of these tests stored in a database. And when the tests start to run, right, we start storing the test results in the database. A couple of things that are interesting here, right? We see that we run all of the tests, right, and everything went good here, right? In this specific case, for this fork of the project, they did a pruning of the test suite. They removed the tests that were not useful for their fork, and so we don't need 40 machines to run the test, right? So we use just 30, and it's taking an average of 1 second to run each test, right? Let me go to another sample. This is another sample. This one didn't went as well didn't went as good as the other one. So we do have a couple of environment errors and a couple of errors. 75 scenarios, test scenarios have failed, and down here we do have the messages for each of the failures, right? So you can, every time you you run your whole suite, because it takes a long time to run, after it's done, you can come here and take a quick look how it looks and check for the failures, right? For example, we do have here, like, let's go for this one. So we have 3 failures and the message for these failures is this one. So we are grouping the failures by message, right? And you can come and take a look and see the whole stack trace, and check what's wrong, right? And this big number here, this is our test scenario code, right? This number looks like this because we actually create a test tree. Okay, we have like one for the business, and one for everything,
Gabriel.
2 for the business. Sorry.
Gabriel, Paulo Petin showed us the environment tree, and so this number comes from the environment tree, right?
Yes,
okay.
Exactly. And next for the reports, let's go. We can then check the history of this scenario running. It's taking a while. All right, sorry. It's a little bit slow here. I do have one of the samples open here. Mm-hmm. So it's going to open the same screen as this one. Here you have the history, the whole history of the tests running everywhere, right? So, so for example, if you have a breaking test like this one, you can come here and take a look at the whole history to see whether that error is a common error. So if you have a flaky test, you can check whether if you're gonna see that you have random failures here, right? And so this tool helps you to detect flake tests or to see whether it's just your.
Is this a flaky test, Gabriel? This one specifically, you think?
No, this one specifically doesn't look like a flake test because it's always breaking in the same place, right? It's the same branch. The branch for this one is VIP, right? And it's always in the same place, right? And when it's in a different, it runs in a different branch, it's a different kind of error, right? So this one, I'm pretty sure it's a consistent error. It's not flaky, right? So the whoever has this, we have
This
our
branch.
yeah, in this branch he has to fix this one, right?
Okay. Let me know who it is so I can fire this person. Okay.
All right.
I already fired Paulo Petin in the previous episode.
Okay.
He had bugs on his branch too.
All right. So
Alex is laughing. He likes my management style.
It's real safe for people to fail their tests.
Very safe.
So here's the same report with a different view, right? So like I said, we do run the tests in multiple servers. It's one of the greatest things about our testing frameworks. It's that it's very distributed friendly, I'd say, because when you want to run more tests at the same time to speed up, you just spin up a new server and run this suite and connect to this server, and it's good to go. It's interesting this view because you can see where the failing tests are, right? For example, like I have a test failing in this machine, right? Sometimes when you have flaky tests, for example, or something that's, let's say it's failing because of the something that was changed in the environment by a test, you're gonna see something unusual here. Like in this one server is going to have like 100 failures, while the others are going to have just 1 or 2 or 0 failures. Then you can easily spot, for example, that okay, if I have one server with like 100 failures, probably I do have a test that's breaking up the environment in a way that the tests that run after that are just going to are just breaking because of the other one, right?
An unexpected side effect.
Yeah, it's and it it's pretty, it's unexpected, but it helps a lot when people read the report, right? And finally, for the reports, I would like to show just this one, right? This is just any statistic of all the suites we are running, right? For this specific project, for example, here we have five suites running. Here we have 6, and here we have the quality of the test execution environment. So, for example, most of the days, all of the executions go up to the end. So why do we need this kind of stuff? So like I said before, we use the AWS spot market. The spot market, one characteristic is that it is cheap to use a machine, but Amazon has reserves the right to just take the machine away from you, right? So you don't, it's not for sure that you're gonna keep the machine until the end. And then when that happens, this kind of thing can happen, like you see here. So sometimes a lot of suites just don't finish. So this is the kind of thing here. We also have statistics for the average time of execution, right? This medium is we sum up the tests run for all of the machines, and then we calculate a median, right? For the total is for the total suite, and this execution is the actual test time execution, right? The total median, it has some setup that's not part of the test, and that takes up some time. And here we have the average the average time that it takes to run each of the tests, right? Sometimes it's good for you, if it's pretty good if you want to detect like performance issues, right? So if this is like going stable, you know that your suite of tests and your tests are running you're not running ruining the performance of the execution, right? So if you start to see this like going up, you're gonna know that something's wrong. Someone introduced something that affected the performance of the whole application, right? And here we have the count of scenarios. It's increasing. It's right. You can see that at the beginning of the month it was 46, and now it's 46,161, and then now we have 46,280. Right, you can see that it's always keeping up, meaning that people are still working, creating new tests. And finally, this is just like to another statistic to see whether our environment is good, right? So if we have, we expect to have in this case 40 machines running the tests, right? But we can have some days like this, we have 30 machines instead of 40. This means that that we are losing spot machines due to the spot market instability. So it helps us to understand whether our environment is stable, right? Right. So this is for the whole statistics and reports.
Very nice. Thank you.
Yeah, very interesting.
How do I? Oh.
So, Ed and André, who wants to show from your side first what we have?
I can show some tests here. Let me share my window. Cool. So this is a merge serves tests switch for a specific chain at Nubank for collections. This is the depth EGN file. So we are using the tools depth from Clojure for building the project. So this is an external dependence, like it's just some library, and we are getting it from Maven. And here you can see that we are require the local services. So yeah, it's called BuildGauge, and it's a microservice. And we are saying that the location of this dependency is at this directory, right? So it's local, and it's just a folder. It's not like a jar artifact. So if we go to the repositories folder, you can see that we clone all the services repository that we include in this project. This is how we require all the, like this is how we declare all the services. So basically we just specify that this is the name of the service, and this is the set of components that we should consider for this service. So we are always using the test components. So in the test component, of course, like the HTTP component doesn't actually make HTTP requests using the network. So I can show.
They're resolved locally in the same VM, right?
Yeah. So I have a REPL running here.
André, you have all these services running on the same JVM. How do you handle like libraries and different versions of libraries? Do you have separate class loaders for them, or how do you solve it?
Yeah, great question. So we are using, as I said, two depths from Clojure. And two depths has a probably unusual way of like solving the problem of deciding which library to load if there would be multiple versions of the same library. So like I know Maven has a strategy for that. I think it's adapt first search or something like that. But in the case of two depths, if there are two versions of the same dependency, each picks the newest one. And this is because Clojure, it has a culture of not breaking stuff. So if you bump a library version, like this should not be a problem. You should be always be able to bump libraries. They shouldn't break anything. So here at Nubank,
I see.
We try to avoid breaking chains. And in this way, we expect that if the latest version of some library is picked up by two dApps, it will work. This is mostly true. Sometimes we do need to make breaking chains, and this is okay because like we are dealing with our internal libraries.
Okay.
But most of the time it works fine. You don't have to worry about this.
Okay.
So maybe I can show an actual test. So
I think you put an apostrophe there. Did you remove it? Or was it just
this is like some Emacs specific issue. It's not really there.
Okay.
So I can run some tests here, like this one, and this is executing code from multiple services. The first one is slower for some reason.
Which one are you running, André? Open collection or does not close collection? So closes collection one page. Okay.
Yeah, this test. And just to show you, like before I show the implementation of this test, we can generate sequence diagrams. So I will run it again. And we can see all the actual interactions between services, all the HTTP, Kafka, and the database stuff as well. It's running. Okay. For some reason, my MacBook thinks that SVG should be opened with LaTeX app.
Emacs, LaTeX, wow, this is cutting edge tech.
No, this is like the open macOS command. Don't blame Emacs. And this is the result. So this was generated right now. So here you can see the names of the microservices, right? The first thing that happens in this test is that feed, which is a service, consumes this Kafka message.
André, Sophia showed us something like this inside a single service, showing the calls to the mocks and stuff like that. So now you're showing these calls across services. Is that it?
That's right. Yeah.
Okay.
So each one of those is a service. So you can see that this arrow, each comes from nowhere. Like no service is generating this. So this means that this is a message produced by the test. So somewhere in the test, we are producing a message. We are producing this message, right? So feed consumes this message from this topic. And as a consequence of this, feed produces this message to this topic. And as you can see, this diagram is huge. And those are the Kafka interactions. And I guess you can see the HTTP as well. It's like the yellow boxes. Those are the Datomic, which is our database interactions. So this service is persisting those datums. And there's some stuff in gray. This means that this service is actually mocked. So we are not running flagship. We are mocking its response here. Because like this service is not important from the collection's perspective. And we can easily just mock the responses. Because if we had to include every single service that participates, we would have to include probably dozens of services, and it would get really, really slow. So we do have to step some stuff that is not important for the flows. So I can show you the actual test. We are using the same testing library that we use for the integration tests. Maybe the name integration is a bit misleading because at Nubank, the integration tests work at service level, and they mock all the external interactions. So we use Stateflow, and let's say this is how we let's say create an account. First of all, we need to set a date, and this date it is important for some flows, because let's say you want to pay some money, then like the date that you pay is important for paying a financing, for example. Here we can see how you can buy, how we simulate a customer buying stuff. So I can go like to this function, and we are producing a Kafka message. So the framework puts this message into a queue, and it knows how to send the message to the other services that will consume it, right? And if you include a new service in this test switch that consumes from this topic, it will start consuming this message in this test automatically. So we are not saying here which services have to consume this. The framework knows how to discover that.
Okay.
So for testing like the actual side effects, usually we hit some service and we check if the result is the expected one. So usually this is the way we do assertions at a multi-service level. Right, so I think it's nice to show how we organized our tests, our financing tests. We thought about a set of invariants, and we created a set of tests that in the end they run, like they test if those invariants are true. So we worked in collaboration with the business people in order to map the invariants from a refinance promise. And this is like just before the implementation, before writing any test, we discussed what were the invariants that made sense for this product. So, for example, we know that the principal of refinance promise should be greater than 10 reais. And this is always true, regardless of the other conditions of the refinance.
André, we're thinking of having an episode in the future about generative testing. Are this idea of invariance, is this an influence from generative testing? You know?
Like yeah, I would say so. It's an influence from generative testing, but the big difference is that we are not generating data for this kind of tests, but we could. It's just not implemented yet. It's probably way more complicated than doing this at the function level, because it's harder. I believe it's harder to generate inputs that make sense.
Many more combinations, right?
Yeah, there are many more combinations. So let's say a customer might contract financing, and the customer can pay, and the customer can get late. But only a few of those secret combinations of interactions actually make sense, right?
Okay, so I invite you to watch the generative testing episode.
Cool.
Here, this was part of the specification, right? Like sitting with the business analysts and the product managers, like what must be true on this scenario that we're testing, and then you write this down even before you write the test in the code, right? And if I understand correctly, they then turn into assertions at the end of the test. Like at the beginning,
that's right.
True, and at the end, it needs to be true as well.
So, like, if we go to this project, invariants, let's see those invariants. So we run all those checks for anytime we run a financing test. And the cool thing about those invariants is that they can test data between multiple services. So, for example, we have a service called double entry, which is our book account service, and we can check if the value of some book account matches the financing amount. So, like, this value comes from one service.
Okay.
And so we are testing against behavior against multiple services. And this is really like unique for end-to-end testing.
You can have cross company invariants.
Yeah, that's right.
Okay.
Well, I guess that's it for the multi-service tests.
Thank you, André. And I'm now really curious, because here it's really clear that this is written by programmers, read by programmers, kind of like it's a little bit different than what Eden said in terms of trying to have a DSL, right, that anybody could read. So could you show us how that one is different, Eden?
Sure. So, okay. Okay, so here it's a test for.
If you could just make the screen a little bit larger, because it's really hard to read at this point. We just have to scroll.
Or make it smaller, then we don't even try to read it.
Maybe easier. Let's just so set font. So I guess, and let's just for now. It's
Marcelo,
better.
can you increase the screen? There you go, Marcelo.
Wow, produção.
So here we have like someone like this for multi-product is when you ask for both like a conta and a credit card. So here this flow is described from a previous flow. So this flow here is another test that we test something else, and we want to test something from there forward. And so here we say like this is the background, like the person answers the acquisition flow for multi-product to conta only, and then let's assume that they will be accepted to credit card. So then Alice applies unsolicited on the page, and then she receives the email like for global credit card, is the previous one, a little wrong here, and it receives the invite for the credit card cross-sell that she just asked. Between here and here, in acquisition, I think there's 5 microservices, and we mocked the part that run the models to decide if that checks the credit and everything else, because it's another thing. And shortly I will show what that means, that mock, how it looks. But there's a lot of things between the first one and the second one. But what it means to us is for the customer, there's nothing. They apply and they want to answer. There's nothing between those 2 steps for them. And after that, they see on the cross-sell in the credit card widget. That's because it's already a customer, right? It's already have a conta. So if they open their app, they can see on the widget that they were approved for a credit card that they asked. And that widget is saying like you have to finish the cross-sell registration in Portuguese, but I think they get it. And then they answer that flow, and then they see that we are analyzing their docs, and that's what it's saying here. And then an expert, one of the people that does the customer service, looks at the pictures and see if everything's it's all right, and it votes okay. So this customer it's okay. So after he votes okay, there's nothing else for him to do, and then there is no more flow for the customer to finish, at least in acquisition. The acquisition work it's done, and they have a credit card account, and they have an account account. So this is the entire cross-sell flow for you to ask a credit card after you have an account. Summarize here, and all this interaction is live, and I'll show now running the test here.
And Eden, just like you mocked the model for approval, the XP here is also, you're just mocking what the result will come from what in real life is a manual operation, right?
Right, but it is a manual operation, but there's an endpoint, right? Is a web page that they click a button, and that's another level of documentation. I can go on into here and see what is the endpoint of that vote. So if Xperia says, like, I'm trying to vote here, it's not working, I can use this to know what that means. What means voting? Here also there's that level of documentation too. So,
but you keep in the previous level, you keep all interactions at the level of a user, like a customer or an XP.
Exactly. Yes. Or I think we have even some analysts, like there's some interaction that analysts have on the system that we model as well.
So it's a very, very high level. It's looking at the system like a black box, like from a point of view of someone outside Nubank, right?
Yes,
outside the
exactly.
system.
Yes, and there's of course we have like what that means. So for example, what it means on the system to that Alice is seeing the app in the widget in the app. So is this like there's a value there on a JSON that is responsive of a request, but we tie those things together. And one advantage of that as well is that a vote on a customer is a vote on a customer, no matter what customer or how they got there. A vote is a vote. So you can reuse that step in a lot of places, and we do that. So I'll just run the stats quickly because then like it's loaded, then I run the tests. This. So what's happening here? What's all these things? So we print on real time as we are running the tests, the interactions that are happening. So you start with a register, and then there's requests and messages, and more requests and more messages going into other services. And why this is useful. So I think a lot of people can see why this would help, but if you are used to the system and you work day in, day out, usually when there's a problem, you can look here and have an idea where the problem is. Like it won't like say exactly what the problem, but if it breaks from here and here down, there's nothing more. Okay, so I have to go between Villa-Lobos and Vitrine to see what's happening. So that's another thing that we have, that every time that we run, we print it again. And this is deterministic because, like I explained, is depth first. Every time will be the same. And to show
so these are all Kafka messages and HTTP requests, just for the small flow that you showed us.
Yeah. Actually, not just for this, like
flows.
for the entire flow. Yeah.
So they're not real Kafka messages or HTTP requests, right? We're just saying they would happen in the production environment, but here we're actually skipping that network layer
and calling code directly. Yeah. And I want to show, for example, here we did all this and we gave the customer the credit card account that they asked for. So if I go here on the service, you have to believe me here, but what I will do, I will introduce a bug here. So this to originate is what create the credit card account. So I'll save here. I will load this namespace, go back to the previous one, load as well. Let's just clear here, so it's easier to see, and I rerun again. And it broke because we didn't create the credit card account that we said that we would create. And we can say here, like there's a lot of jobs, there's originate of savings account, but if you're used to, you say, oh, okay, so it broke, we didn't create the credit card account, I will go to the service that deals with that. So this is the services. So if I go back here, okay, load. Let's just clear here again. And then I run again, and now the test will pass. So that's it's not that the test is fast, but interaction with the code itself is fast. So yeah, and just a little about the DSL itself, how we thought about it. We try to think like there's a session. You can a little like you would have a session on a web page or in the app. Like there's a session, and is stateful. So this state is being saved somewhere, and in this case, for example, when she applies, the application is saved here in Alice application, and we can use that further down. And this signing, for example, is something that happened in the past, and we can use that. For example, the credit card widget. And it's pretty important for us, this idea of focusing on what the user does, because, for example, here, sees the cross-sell flow, and we could put this function here, But we chose not to do that because it would make more sense the flow, like when we read, to be separated. So that's either way the test would run, would pass or not, but that was a decision because of how the flow would have been implemented and be read. And just go ahead.
I remember, Eddie, are you going to show the diagram?
Yeah, that's I will go now.
I remember you guys had a diagram for similar to André.
So we have that. There's two visualizations that we created. The first one, let me see if I can find it here. So 1 second. Here. Okay, are you seeing there? So this is a best one. We have more tests than that. I think there's 70 and something. This it was a previous one, but just to show why we stopped of creating the like that. But this is basically the branching. If I show here, there's this background, right? So it's a previous test, and this continues from there. So this is the idea here. So this is the main test. So someone applies and accepts the credit card, then receives the invite code email. That's like the first thing. Then there's branching from that. So given that we removed the invite code, so newer customers at Nubank, like newer, like the last year, a lot of people don't have the invite code anymore that they need to put on the app that people that are older Nubankers had. So here we are testing this. We are branching. There's a version without the invite code. There's a version with the invite code, and therefore there's new integrations. This is integration with a new service. There's a new way to validate email and so forth. But this can become pretty unruly fast because it's a tree. So only branches never converges. So quickly becomes not that useful. The other visualization that we are using now is more focused on the business sides. We don't have still yet the same visualization that André showed of a sequence diagram, and we are now talking about converging those two frameworks so you can have both. But if I show here, I think I can find, if I open here, this is the handling of all these steps and scenarios. So for example, here is apply to multi-product and is approved and release only for no conta full and is published for cross-sell. So a lot of words that mean something to someone working in growth, but this is just the journey. This is the journey that the customer will go through, and there's a lot of them.
Do business people understand this language?
Yeah, they do. Yeah, this is the words that you use day to day to talk about stuff. So what republish means, like in a lot of places, can mean a lot of things, but in growth there's a specific meaning: cross-sell and conta and everything else. Release it. Release, for example, is when we give the product for a customer, for example.
I'm glad at least they understand this.
And we can go further. Now, okay, what happens here when someone applies? So this is what happens. They apply to multi-product and it's a set no conta. Then they engage, they complete the flow, then they expire vote. So there's more here. So the idea is, if I don't want to know what is this, I don't have to. If I do, I go inside, and we can go keep drilling down. So this is the steps on the scenario, and we can see like this is the services that are used when someone applies, and this is only the services and mocks that are in our tests, because could have more, right, that are consuming that we don't know. So this came from a requirement from the experts, because they didn't know what service was involved in a specific step. So they want to know that so they could correlate with other bugs that were happening or some crash that was happening, for example. So that's what we add these services on the steps that ourselves can use, our engineers, because a lot of times ourselves don't know without checking some documentation. Most of the time we don't know. So that's what was the requirement. And the way the framework is implemented, we have this data. We have the service data, we have the request data, have the Kafka data. It's just about using that data to create a new visualization.
To render, very nice.
Yeah.
And then, so the DSL makes it easier for anybody in the business to understand what the test is doing, but has anybody other than software engineers written tests using the DSL, or is it still mostly, you know, the engineers writing the?
It's mostly engineers. There's no one on product that actually wrote a test. We had some meetings where our engineer gather data from the business people. One of those actually it illustrates what we want from that. We were just discussing the application, like you apply and then use the invite code. We thought that we would have an entire flow in our half, and our half was just in those steps, because it's a lot of things that happen, and there are a lot of things that even the business people weren't clear in what happened in the back end, and there was a conversation. And that's like the value that we in growth, at least, that we want more from this. Like, is a formal language for the system, right? So if someone describe to us, we need to describe in a formal language. If we can't, we need to go back and ask for more things. And that definitely it's happening. So there's a lot of new features that we implemented that we relied on this acceptance to like do the first tests before going to production. And that back and forth happen a lot. Every engineer has a little way to use the acceptance. Some write the test first and see it breaking. A lot of features that doesn't even make sense. So you don't go there. Someone only run afterwards. But it's something that even if only engineers write those tests, keeping it high level is useful, because the conversation is easier. We always keep on the level that everyone is talking about.
And just switching back to Gabriel, then, is like, is there anything similar to a DSL in the test set objective? Do you have folks other than engineers writing down some of these specifications, and how does it work for you all?
Yeah, we do have some projects that where we can write tests in DSL. We do have a different approach. I find this subject very interesting, and I really enjoy these charts. Really nice. I really like the way you can describe formally, so that a business person can read the tests, right? And we do have a little. It's a little bit different the way we do and we did, but I would like to show you our approach. Just trying to share my screen.
I remember some of these discussions at Objective and at Nubank, and these discussions are like oral tradition. You know, it's the code and oral tradition, nothing else. So you know, and people are disagreeing about what the system actually does. So they have to look at the code to see what the system does, and then this way it's like much easier, much more direct to know what happens, right?
Yeah. So here I have an example. So let me tell a little bit of history before this happened. So there was a time in this specific project.
Can you increase?
Yeah,
like,
sure.
Could you increase the font a bit? Thank you.
Like this? Is this good enough?
A bit more.
Okay, like this. Let
Thank
me
you.
try to take this away. Okay, better. And well, at that time, we had a product manager. He was telling us the features he wanted to be implemented and discussing technical details. And he thought everything was wonderful. Everyone was understanding everything he meant to, for us to do, but the fact was that we weren't, and we had a serious communication problem with that specific product manager, because he said he described the business rules in his language and in his way, and for him everything was so simple. And he said, "Oh, then you draw. Uh, can you see this chart? Then you draw the line, and when it crosses the other line, and here is what you have to do." And we said, "What?" We had, sorry, but we don't understand. And at some point, some of the developers just got tired, and they kind of pretended that they understood what he meant, and they went there and coded what they thought he wanted to us for us to do. And obviously that didn't work out very well, right? So it was the communication problem was so serious that some of the developers were getting stressed about that, and in our retrospectives they're saying, "I can't understand the product manager," right? And I'm getting nervous and I'm getting stressed, and I'm losing nights of sleep because everything I implement is not what he wants. And then we were writing tests the way we always did, and it was covering code. It was helping us to model the project. We are doing a lot of TDD too in this project, but it didn't help because the problem was not just about the test, but the way we communicated with the product manager. So we decided that we wanted to go a little bit further in the way we write tests. So we wanted to write tests that the code of the test itself would be the specification of the feature and the test case that the product manager wanted. So we started to doing some experimentations on writing tests like this. So like given a project, the current week date, right, and then we have then first week between current week date. So this is much more readable than the regular tests, right? This is Java, by the way, and we wanted to make sure that we had all the indentations in a way that we could specify the test case in a way that when we show the test case to the product manager, he would understand the test case and say this is correct or it's not, right? So here we have what's given, and then we say, okay, when a function is called, okay, then the following things are true, right? At this date, this in the scenarios inherits from this date. So this means something for the business, for the product management. It means something for the developers as well, right? So I'm not saying everyone will understand this specific case, but I'm saying that it's readable. It's readable in a way that we can talk and explain, and we started to teach that specific product manager to write tests like this. So we said, so this is a way to specify tests. Okay, you can make up your words. Don't worry. Okay, you can make up the words you want, right? And you put it here, right? And then you can explain that word for us, and then we can, and it's all good because he made up the word that means something for him, and explained it to us, that specific word, and we could start evolving the specification of the test, the code, until we got we converged and we converged, and we were sure that everyone understood what was supposed to be true after the test run. So with this setup, these things should be true in the end. Right?
So the oral history becomes written history. Not only that, it's executable, right? And then that agreement is written in code and can run.
Yeah, so I know it's not as pretty as the card box that Adam just showed us, but this is good enough for a business person that is not just a technical, a person that understands a lot of the business can be taught to write tests like this. And we did teach him, and he just pick up the slides. So he had the specification was a bunch of slides, and then we told him, okay, so at the end of each specification, you write this for us. Okay, make up the words you want. Just make sure it has this structure, and then we can make it happen. Okay, whatever you want to make up, don't worry. Make sure you understand. You can explain very formally, and then and then and then what happened was that we just ignored most of the stuff he wrote in the specification. We took up this code and we paste in the in the in the JUnit test, right? And then we started coding the test, right? So of course it takes quite some work for you to write the DSL like this, but I'm at least for us it was a very good experience of making sure that we communicated with our product manager. And so the product manager was happier and the developers were happier because they understood what he meant, and at least they knew what to write and what they should do to make it work. And I'd say that today this project continues to do that. We are improving the DSL, right? This is not perfect, but our goal is to make sure that the test says what the business rule, right? The business rule must be here and very formally, because in this way, the test is not just a test to make sure the code is working, but it is a way to document in a very readable way. We had other improvements during the code review, because when you throw up some code like this for someone to review, it's much easier to understand what the developer means. And actually, sometimes we could take this code and give it to the product manager and ask him, okay, review it. And he did, and he was able to say, okay, you got it right. Or he said, oh, I am analyzing the dates here that you put the parameters, and I made some calculations, and this is incorrect. It's not correct.
Wow.
And then we could go there. Oh, really? The test is wrong. So let's fix it.
Mm-hmm.
Very nice. I was wondering, we're talking about acceptance tests, if eventually Gherkin would show up and this given when then style, right? It's like there's this dream that a pure DSL, it's text-based only, it's what people are going to write on, but at least I've never really seen it play out, but because you still have it in Java, right? So the PM had to learn how to write a bit of Java and still making that translation. It's very, very, very interesting. Thanks for sharing, Gabriel. I think we're running on our time limit here, but before we go, and for those of you that are still here with us after looking at the code and stuff, hopefully you're gonna get the biggest payoff, because I understand we started this series because we know a lot of people are not even writing any automated tests, and we wanted to not only show you folks write automated tests, they write their own frameworks to do end-to-end testing and acceptance testing really quick, and use the cloud and create diagrams and get PMs to write some of the code. And why would you go through all this trouble? Right? So I would love, because like I don't even want to start. This seems like a lot of work. I would love to hear some stories from you all. Like that feature where, oh, without this, I wouldn't have understood it. And it was so clear afterwards what we had to build. Or that regression is like nobody could find the bug, but with this one test, we're able to pinpoint it and kind of fix it. So it's like, is there any these tests save my ass kind of stories from you all that would help other people realize the benefits of actually doing this type of work?
Some gains like Takeuchi just shared a story with us about the gain of communicating with this business person, and it was, stories are always nice.
Yeah, I think one that comes to mind, like I said, we used for debug, but not one specific comes to mind. But one was about what shouldn't change, we were creating a new service. We were refactoring our process to pass through a new service, and we were like extracting things from other services and putting that service, and that should be
inter-service refactoring.
yeah, and that should be totally transparent for the customer. So basically, the test shouldn't change, and that's how we use the test. Like we only had to add the service on the list of the services that we have in the test and run, and it should work. That was it. And that wasn't it, obviously. Something went wrong. But the test was like that base. Like if we define it the how the interactions like it should happen on the test, like more technical, we wouldn't have that ability to say like this shouldn't change. Like the customer, he doesn't care about this. The expert doesn't care about this. It's something that we care, so it shouldn't change that test. And we did that like, and was like in beginning of the last year, like we did in the acceptance test. We get some bugs from there, and when we went to production, it went to production and it worked. So I think that's one of the biggest values of the place we are now in our team. We are doing a lot of that. We are doing a lot of changing the backend code, but it shouldn't change nothing in the behavior. So we want to see those tests not change at all, but the backend code is changing. And yeah, I think that's one of that I most remember because of that ability of the test. Like that's if it matters, it doesn't matter for the user, so it shouldn't change on the test. So that's the idea, and we were able to do that, and we continue to use that, and we use more and more for that because we are in a place that we are doing a lot of changes that it shouldn't impact the customer.
Yeah, I would like to share a story. I think that's the objective story. I could talk about a lot of examples of things that technically saved our ass, and we found out that if the tests weren't there, I would just get screwed or anything like that. But I would like to tell one case is that I think that's the most value we got from tests ever today is um, one of our main customers that is our customer today. It's Oi, right? The telecom. And when we got a contact at the time, we had the system in Smalltalk, like we just said, right? And we were there was one of our commercial, one of the salesperson got a contact from Oi, and they explained how wonderful our system was, right, to deal with people, and how and that it had a lot of quality, it would save all of their problems. But and they said, oh, that's amazing, how nice, but there is a problem. And what is the problem? It's in Smalltalk, and we don't buy it, sorry. And then we thought, oh my god, we had the possibility to make the deal, one of the biggest deals ever for our company, and our system is written in Smalltalk, and we can't make the sale because of that. And it was because and the tests that we had was what actually saved us, because it was what made it feasible to convert like 3 or 4 million lines of code of complex business rules in about 2 years or less, actually. And in like a year and a half, we had the whole code converted to Java, and we made the sale. We got the customer. So I would say that's the best story ever. So if you can make like big bucks and get a customer like Oi, just because you have tests, so why aren't you doing this right now? So please start testing, because you're gonna make a lot of money because you are testing.
Thank you, Gabriel. Very nice.
Amazing, yeah.
André doesn't have a story because his code is perfect, so he just really needs as a test. It just always passes, you know.
Well, I guess one of the biggest gains from mode service tests is getting documentation, because like even if you have like the perfect framework for mode service tests, it's still not obvious what has to be tested. So, and when you think about the what you should test, you end up discovering a lot and thinking a lot about the product. So, like there was this project that in which we were replacing all the financing infrastructure at Nubank, and the issue is that we didn't understand very well the legacy service, the legacy infrastructure, and when we created all the new services, the new infrastructure, we made sure that we agreed on the set of invariants, on the set of rules, and that we expressed this in code in the test switch. And this is great because now we have a properly documented product.
This invariant approach is really interesting because you can sort of go wild in your tests. You know, you can have the invariants check your. It's really interesting. Yeah.
Yeah, I mean the thing I see in that story there, André, is that before we couldn't really tell what the business logic was unless we opened the code and read the code and then actually connected the hundreds of microservices and messages and callbacks, right? But after we went through this experience, now the business logic is clearly documented in an executable format there in this test. So I think that will pay dividends for many years to come. Yeah. This was amazing. Thank you, guys. I'm just really mind blown in terms of the depth of some of this discussion and the different approaches that kind of create that same safety, right? Yeah, we're building something that works and it works from end to end, even though we don't need to like test in a clone of the production environment. We want to test across the multiple boundaries of the components or services of our system. So I really enjoyed it. Thank you so much for sharing the time with us and showing the examples.
Thank you very much, my friends. Hope to see you guys soon.
Thank you for the opportunity. It was really nice.
Yeah, same here.
And I will see you in the next episode, dear viewer. Thank you for sticking with us.
Bye-bye.